Good morning, all. Am I audible? Do let me know in the comment section. I hope I am audible. If there will be any problem will come, do let me know in the comment section. Okay. So let us start the lecture. So as we already discussed the fundamental basics of three-phase circuits, and we saw basically in three-phase circuits we have two types. One is called star-connected circuits and another one is delta-connected circuits. We saw the difference between both and we saw how to calculate the voltage, current, impedance, power, all the parameter calculations in both star and delta connected network in terms of given previous year questions. We have just gone through and from each and every question we did so many analysis, right? Yes. So let us continue the lecture one more time. I will be solving 2-3 more questions. After that, we will go ahead with the next part of the network theorem that is called two-port circuits. So first, let us complete this basics. Okay, there are two more questions to solve. So while solving the question, you have to put your effort continuously. Okay, be dedicated. Every day, keep smile while solving the problem. It doesn't matter how many truffles that you are facing, it will be there. Every side, எல்லா பக்கமும் இருந்து நமக்கு அடி விழுந்துட்டே தான் இருக்கும், டிஸ்டர்பன்ஸ் வந்துட்டே தான் இருக்கும். பட் எவ்வளோ டிஸ்டர்பன்ஸ் வந்தாலும் யூ ஷுட் லேர்ன் அதை கரெக்டாக மேனேஜ் பண்ண கற்றுக்கணும். கீப் கண்டினியூவிங் யுவர் எஃபர்ட், டோன்ட் ஸ்டாப். லைக் ஒரு சிலர்லாம் ப்ராப்ளம்ஸ் வரும்போது என்ன பண்ணுவாங்க அப்படின்னா, ஒரு சில அன்வான்ட் டிஸ்டர்பன்ஸ் வரும், இல்லை அவர் செல்ஃப் வந்து என்ன ஆகும் அப்படின்னா டிமோட்டிவேட் ஆகிடும். அவ்வளோதான், டிமோட்டிவேட் ஆகினா பங்க்சரான டயர் மாதிரி அப்படியே உட்காந்துட வேண்டியது. திரும்ப அதை நம்ம சரி பண்ணி பம்ப் பண்ணி யூஸ் பண்ணுறது இன்டென்ஷன் வர்றதில்ல. இப்போ டே பை டே என்ன ஆகும் அப்படின்னா, ஸ்டார்டிங்கில் வந்து 5 hours படிப்பீங்க, அதுக்கப்புறம் 4 hours ஆகும், தென் 3 hours, அப்புறம் 2 hours, கொஞ்ச நேரத்துக்கு அப்புறம் ஒரு 1 hour, அப்புறம் ரெகுலராக 4 o'clock எழுந்து படிச்சது 6 மணி வரைக்கும் தூங்க ஆரம்பிச்சிருவீங்க. அப்படியே இட் வில் பி ஸ்லோலி கோஸ் டவுன். ஸோ தீஸ் கைண்ட் ஆஃப் இஷ்யூஸ் வில் ஹேப்பன் டியூரிங் தி ப்ரிப்பரேஷன். அதனால என்ன பண்ணணும் அப்படின்னா, ஐ எம் நாட் கோயிங் டு சே எனிதிங் டு டூ திஸ். ஜஸ்ட் இன்க்ரீஸ் தி இன்ட்ரெஸ்ட் ஆன் யுவர் சப்ஜெக்ட். லைக் நான் ஏற்கனவே சொல்லியிருப்பேன் இல்லையா, எக்ஸாமுக்கு வந்து ப்ரிப்பேர் பண்ணும்போது பேசிக்காக வந்து நம்ம எந்த ஒரு விஷயம் எடுத்துக்கிட்டாலும் அடிகள் அப்படிங்கிறது வேலைதான் செய்யும். ஸ்டார்டிங் எடுத்தோடனே நம்ம வந்து மாஸ்டர் ஆகிட முடியாது. ஸோ நீங்கள் ஸ்டார்டிங்கில் ப்ரிப்பரேஷனில் இருக்கும்போது யூல் பி கொஞ்சம் ஸ்ட்ரகிள் ஆகும், நிறைய கொஷனுக்கு ஆன்சர் வராமல் இருக்கும். அது சம்டைம்ஸ் இட் மே லீட்ஸ் டு ஃப்ரஸ்ட்ரேட் ஆக வாய்ப்பு இருக்குது. பட் வாட் எவர் வில் ஹேப்பன், ஓகே, தட்ஸ் ஃபைன். ஸோ கண்டினியூஸாக வந்து நம்ம எஃபர்ட் போடணும். கொஞ்சம் ஸ்மார்ட் ஒர்க் பண்ணுங்க. ரொம்ப ஹார்டாக வந்து நம்ம படிக்கணும் அப்படின்னு அவசியம் கிடையாது. கிடைக்கிற டைம்ல ஜாலியாக ஃபன்னாக உட்காந்து ஒரு 2 கொஷின் சால்வ் பண்ணி பார்க்கலாம், கொஞ்சம் கற்றுக்கலாம். அந்த இன்டென்ஷனில் படிங்க. ஐயோ எக்ஸாம் வரப்போகுது, எக்ஸாமில் நம்ம ஃபர்ஸ்ட் மார்க் எடுத்தா ஒன்றும் இல்லை, எக்ஸாம் நம்ம வாழ்க்கை, அதுதான் நம்ம உயிர், அப்படி இப்படின்ட்டு ஏதாச்சும் வந்து நீங்கள் பாட்டு லோட் பண்ணி வச்சிங்க அப்படின்னா மெமரி வந்து ஆட்டோமேட்டிக்காக என்ன ஆரம்பிச்சுன்னா ஃபியரை வந்து கிரியேட் பண்ணி விட்டுரும். ஐயோ நீ என்னடா எக்ஸாம் இவ்வளோ இது இருக்குன்னு சொன்ன, இதுதான் உன் லைஃப்னு சொல்ற, படிக்காம ஊர் சுத்திட்டு இருக்க. ஒரு எமர்ஜென்சி ஒர்க்கு நம்ம செய்யும்போது கூட அந்த ஃப்ரஸ்ட்ரேஷன் வர ஆரம்பிச்சிடும், ஃபியர் வர ஆரம்பிச்சிடும். ஜஸ்ட் கூலா ரிலாக்ஸ்டா ஒன்லி திங்க், ஓகே நம்ம நாலேஜ் வந்து நம்ம வந்து நல்லா இன்க்ரீஸ் பண்ணணும் அப்படிங்கிறத மட்டும் மைண்ட்ல வச்சுக்கிட்டு கண்டினியூஸ்லி சால்வ் தி ப்ராப்ளம். தட் வில் அது ஆட்டோமேட்டிக்காக அவுட்புட் வர ஆரம்பிச்சிடும். எக்ஸாம் வந்து டார்கெட், எக்ஸாமுக்கு வந்து 30 days தான் இருக்கு அப்படின்றதால ஒரு சப்ஜெக்ட் 2 நாள்ல 2 நாள் ஷெட்யூல் போட்டு 10 நாள் நான் மொத்தத்தையும் படிச்சு முடிச்சிடறேன்னு சொல்லிட்டு விடிய உட்காந்து படிச்சீங்கன்னா இட் இஸ் நாட் செமஸ்டர் எக்ஸாம். கண்டென்ட் வந்து மெமரைஸ் பண்ணிட்டு போயிட்டு எக்ஸாம் எழுதுறதுக்கா. ஒவ்வொரு கான்செப்டையும் ஸ்லோவா உட்காந்து பொறுமையா இன்ட்ரெஸ்டா உட்காந்து லவ் பண்ணி கத்துக்கணும். இஃப் யூ டூ லைக் தட், இட் வில் பிகம் அ ஃபேவர். அதுவே உங்களுக்கு வந்து ஃபேரா மாறும். இட் வில் ஹெல்ப்ஃபுல் டு யூ. உங்களை அடுத்த லெவலுக்கு அதை ஷிஃப்ட் பண்ணும். பட் continuously do your preparation. Don't stop your preparation for anything. Okay, at any cost. கொஞ்சம் கொஞ்சமா இப்போ ஃபார் எக்ஸாம்பிள் கொஞ்ச நேரம் படிக்கிறீங்கன்னா நடுவில் ஏதாச்சும் போர் அடிக்குன்னா அந்த டைம்ல என்ன பண்ணணும், வேற என்னென்ன எக்ஸாம்ஸ்லாம் இருக்கு இந்தியாவில், அதோட ஏஜ் பார்ல என்ன, அந்த மாதிரி நம்ம எக்ஸாம் ரிலேட்டடான விஷயங்களை வந்து கேதர் பண்ற மாதிரி ஏதாச்சும் விஷயங்களை பண்ணலாம். ஓகே, that will be better. Okay. Last time I had given some question, I hope you remember. இந்த கொஸ்டின் நம்ம ஹோம்ஒர்க்கா கொடுத்தோம் இல்லையா. பேசிக்கா இந்த கொஸ்டின்ல என்ன கேட்டிருந்தாங்க, this is for the balanced star to star connected three-phase circuit shown in the figure below, the line to line voltage is given as 208 voltage கொடுத்திருக்காங்க, கரெக்டா? So the line to line voltage, this is the line to line voltage given as 208 volt. அது RMS voltage. Of course, basically நமக்கு வந்து three phase circuitsல கொடுக்கிற voltage வந்து that is line to line voltage, and of course it is RMS voltage only. Next, the total power absorbed by the load is clearly given as 432 watts. So this is the total power consumed by the load. Where is the load? This is the load portion. But remember one thing, given power is real power. Total power in the sense, total real power consumed by the three branches in three phase. Basically, we will be having three branches. When they are telling that this is the total power, it means the power consumed by the real power consumed by the total three branches. Next conclusion. Power factor offered by the network given as 0.6 leading. You know the meaning of leading. Leading means what? This combination is going to be leading means capacitor may be dominated in this circuit. Now what is the question? These are the given. The approximate value of the impedance is at is dash. Okay, I am dropping the options here. You can take 2 to 3 minutes. You can just give it a try and do let me know what is the answer. Option A, 33 at an angle of minus 53.1 degree ohm. Option A, it is in polar form. Option B, 60 at an angle of 53.1 degree ohm. Option C, it is 60 at an angle of minus 53.1 degree ohm. Option D, it is 180 at an angle of minus 53.1 degree ohm. How can I do this? This is, I think, a direct question. I don't think too much time is required for this question. You can just give it a try and do let me know what is the answer. Take your time. I'll be waiting 2 to 3 minutes. We will wait for this question, but I need the answer. That's all. Keep smile in your face. Just think that you are learning something. Don't keep anything in your mind apart from that. Just feed something. Option C, Rajesh. Good. Any other answer? Any other answer? It's a direct question. I don't think too much of time is required. Chitra Devi, option B. Good. Any other? Any other can I expect? just try. It's a direct question. I don't think too much of time is required for that question first. So anyway, spend 1 or 2 minutes. Just from the given data, how can we find? That's all. Kanaga Savita, good. Option C. Very good. Any other answer? Chalo. Let me try to figure out the answer. அப்படி என்ன கொடுத்திருக்காங்க கொஸ்டின்ல? When I was deeply observing the question, they had given line to line voltage. Line to line voltage was clearly given as 208 voltage. Okay, sir. Second, they had given total real power consumed by the network, 432 watts. I'm just asking you a small question. The total power delivered by the source is equal to total power absorbed by the load or not? The total power delivered by the source is always equal to total power absorbed by the load, because energy cannot be created at the same time you cannot destroy it. So here the consumed energy consumed, the power consumed by the load is 432 watts, means same power it should be what it should have delivered by the source. So conclusion is, this is the total real power supplied by the source or consumed by the load. Both are same. Okay, sir. First conclusion is over. Next, power factor offered by the network was clearly given. The value of cos phi equal to 0.8, but it is leading power factor, maybe capacitor is the supreme star now. That's why it is in leading power factor. Okay, sir. Now, in order to calculate the value of impedance, basically what can we do? Impedance can be calculated in many ways. Anyway, the question is, what is the total impedance offered by the load? So to calculate the value of impedance, what we can do is, we can go ahead with the voltage and the current. Yes or no? Simply, if we know the value of voltage and the current, we can easily figure out the answer for this question. Already, they have clearly given the value of voltage is what? 208 voltage, but given it is line voltage. So what we need is, we need impedance per phase. According to Ohm's law, for this we need per phase voltage upon per phase current. What can we do now? Okay, sir. Since we are in star connection, if the line voltage is given as 208, both are star, source also star, load also star. If the line voltage is given as 208, we can convert, we know line voltage equal to root 3 times of phase voltage, or I can say the value of phase voltage will become line voltage upon root 3. So we are substituting the value of voltage here. But how do I calculate the per phase current? This is the question mark. According to the given data, from the given data, is there any possibility? Yes. For the three-phase system, actually, how will you calculate the power, real power, three-phase system? There are two formula. If you are calculating the power in terms of line parameter, then the formula will become root 3 times of line voltage, line current into cos of phi. If you observe this equation carefully, total power consumed by the load is given, line voltage is given, power factor also given. Can you find out the value of IL or not? Sir, it is very simple. Then do it. So from this, we can easily figure out the value of line current. So the value of line current will become simply total power divided by root 3 times of line voltage into cos phi. So if I will substitute all those values, the value of real power will be 432 watts. Line voltage is 208. Power factor is 0.8. So first substitute all the values. So here if you do like that, you will be coming up with the value of line current IL equal to magnitude of the line current will be approximately 2 ampere. And here, one more important thing that we need to observe is basically voltage is reference. We will always keep the line voltage or phase voltage, whatever, at a 0 degree. See what they simply told the line voltage is 208. Did they given any phase angle? If they have not given any phase angle to the voltage, voltage will be kept at 0 degree. So with the help of, with the reference of the voltage, we will be keeping the current. Now, how do I find out the exact position of the current? I know the magnitude of the current. To know the position, phase angle of the current, power factor is given. Cos pi equal to 0.8. From this, if you calculate the value of phi, approximately you will get 36.86 degree. Whether it is leading or lagging, sir. Leading. Question itself, it is clearly given. So, line current is 36.86 degree leading the phase current. Can I say like that? See, according to the given, okay, it is 0.6. Sorry, it is not 0.8. Forgive me. 0.6 in the sense you will be getting 53 degree, right? 53.1 degree. Guys, it is 0.6. So keep 53.1 degree. So the current is leading. Current is leading 53.1 degree from voltage. So that is what we can say. Okay, sir. So now line current can be written as 2 into here phase angle. How do I write this one? 53.1 degree. Remember one thing. If the current phase angle is positive, it means current is leading. If the current phase angle is negative, it means lagging. You know these basics. Already I taught you clearly. Now we know the value of line current, but we need to know the value of phase current. Anyway, the advantage is since we are in star connection. In star connection, line current and phase current both are equal or not? Yes. So if the line current is 2 at an angle of 53.1 degree, then phase current also will be the same. So it will be 208 upon root 3 into line current is 2 at an angle of minus 53.1 degree. So now it is time to reduce this circuit by yourself. Now if I will reduce 208 divided by 2 into root 3, what will you obtain? So if I will put 208 by, we have to take root 3, approximately the phase impedance value, I am writing the answer here, the phase impedance value 60.04 ohm and the phase angle, see in the denominator we have minus 53.1 degree, when it will come to the numerator it will become, in the denominator is it minus or plus? Sorry, in the denominator it is plus now, current. When it is comes to the numerator it will be minus 53.1 degree. Okay, so what can be the correct answer here? The correct answer is option C. Good. Finally, we got the answer. So this is how we are figuring out the value. Okay, sir. Now I have some doubts. Okay, impedance we found, real power, everything we found. Can anyone help me to figure out the total reactive power consumed by the load? I just wanted to know the total reactive power consumed by the load. I need your help. Please do let me know because I don't know how to find out the total reactive power. Can anyone of you help me? Just teach me. Just tell me the answer. Somehow I will try to bring the answer and I will match up with your answer. What is the total reactive power consumed by the load? Do it fast. Try hard. You can take 2 to 3 minutes. But I just wanted to know the total reactive power consumed by the load. Just do it and let me know the answer. Any answer? Take your time, no issues. Any answer? Total reactive power consumed by the load. Anyone figure out the answer? Reactive power consumed by the load. That is what my question. Did anyone figure out the answer? Rajesh, 332 volt ampere reactive power. Savadana, 1 second. 504.35 volt ampere reactive power. Very good. Any other answer? Any other? See, this lesson we are doing only for the purpose of teaching you how to crack the question. This is not the class where I should teach step by step uh, learning. It is not for that. Intentionally, we made these lectures to bring out your brain work. Chitra Devi, 575 volt ampere reactive power. Good. Any other answer? There. Kanaga Savita, 346.09 volt ampere reactive power. My God, see, none of you guys are posting the same answer. I mean, two similar answers. I'm really very happy. Any other? Let's make the choices. There are the four options. Option A, find out. நீங்களே நாலு ஆப்ஷன் கொடுத்துருக்கீங்க. I don't know whether அந்த ஆன்சர் வந்து இது நாலு ஆப்ஷன்ல தான் இருக்கா இல்லை இன்னொரு ஆப்ஷன் தேவையான்னு தெரியல. Uh, only four of you. What about other people? Okay, fine. Solve பண்ணிடலாமா அப்படி என்ன இருக்குன்னு பார்த்துருவோம். Let me remove all other data. Current, I'm just remembering, to at an angle of 53.1 degree. It is leading current now. Okay, just tell me what is the formula to calculate the reactive power. Simply, sir, it is either in terms of line or phase. Root 3 times of VL IL into sin pi. Yes or no? Cos pi already given as 0.6. I hope then sin pi will become 0.8. Finish. Line voltage already given as 208. Line current is given as just 2 ampere. Substitute all the values. Finish. So it will be 208 voltage. It is simply 2 into 0.8. If you multiply all this, you will get the answer. Okay, Sugumari 576 and Gauri Muthu 570. 575.7, so approximately 576. Okay, let's check it from my side also. Let us solve this. If I multiply root 3 with this other factors, I'm also getting 576.42. 576.42. 576.42 volt ampere reactive power is the correct answer for this given question. It's a simple question. Don't think too much. Think simply with the given data. Let me ask you one more question. They clearly told that the given circuit is 0.66 leading, right? Yes. Kanaga Savita. Good, good. Now every one of you getting the correct answer. Yes. I'm just asking you, listen, they clearly told that the power factor is leading. It means in the circuit we are having capacitor or not? Of course, sir. True, there is nothing is wrong. And they also told that the real power consumed by the network is given. It means this circuit may be the combination of resistor and the capacitor. That's why this leading power factor came. May I know the value of this capacitor? Can any one of you help me to figure out the value of this capacitor and this resistor also? Take your time. Just help me to find the value of resistor and the capacitor. Do it first. They only told circuit is leading. So you also know the total impedance, you also know the total current, total voltage, total real power, total reactive power. So it's not a complicated question that I have asked you to find this. You can easily simply find out this. But keep smile in your face. I'm just expecting the answer from your end. R and C value is what? Take 2 to 3 minutes as usual. But I need the answer, that's all. Find the value one by one. First you can find R and then you can find C. Or you can find C first, then you can find R. Drop it in the comment section. Make this session little active. Any answer? Okay. Chalo. Let us. I'm just giving the clue. I'm not going to solve. Okay. See, total real power consumed by the load is given how much? 432 watts. But it is total power. It means what? There are three branches. Branch A, branch B, branch C. There are three branches. So if the total power consumed by the circuit is 432 means first thing to check whether the given network is balanced or not. But in the question they clearly told that the given star to star network is balanced. So that is the beauty of the circuit. Balanced in the sense three branches will consume the power equally. So it is very important to observe whether the network is balanced or not, because if the network is unbalanced, then you may not be able to solve this question directly. It is not possible to predict the value of resistor that much easily when your load is not balanced. Not balanced in the sense different branches having different values. Maybe three branches may not have the same value of resistor. So it is not possible to solve the question directly. In that case, you have to go step by step approach, like current flow through the first phase and the voltage drop across the first phase. From that, you can find out the total impedance. So you must go with the step by step approach. Similarly for phase B, phase C. But the lucky thing is, basically in your examination, the most of the questions from basics will be directly balanced circuits only. Directly from balanced circuit. Kanaka Savita, R equal to 36, E equal to 47.9 farad or microfarad or millifarad something. Micro, good. Sudhumari, 66.31 microfarad. Fine. Okay, let's proceed further. See, I just wanted to know the resistance per phase. As usual, see, let me do. If the total power given it is for three phase, I just wanted to know the power per phase. Any one phase we can take because system is balanced, you know? So what I'm doing is to know the power consumed by per phase. I'm dividing the 3-phase power by 3. So if you divide it by 3, it will give you the power consumption per phase. Yes or no? Similarly, how do I calculate the value of reactive power? Just think, already we know the reactive power. So I hope it will be, let us calculate this, 1 remaining 144 watts. So the power consumption per phase, the power consumed by the resistor in one phase is 144 watts. Yes or no? Yes. So I know the resistor power per phase is 144. It should be equal to, can I write like this, per phase current I phase square into R phase. Is there any mistake? No, I am just considering magnitude. So resistance per phase equal to real power consumed by the resistor per phase divided by per phase current square. But we know our current is already 2 ampere. Line and phase current both are same in star connected system. So I can substitute the value of 2 here, but it is 2 square. Why? Because it is I square. So it will be 4. So next thing is 144 divided by 4. If you are dividing it by 4, what will be coming up with this? 3 times of 4 will be 12. Remaining to 6 times will be 24. So it will be 36 ohm. So the resistance per phase will be 36 ohm. To calculate the reactive value, that is capacitor. So many way? Yes, of course. See, unit power. Yes, you also know the impedance. If you know the impedance, Z square equal to R square plus XC square. This is one formula. We know the value of resistor, we know the value of impedance. It is very easy to calculate the value of capacitive reactance. Another way is, you know the reactive power as usual in the same procedure. Per phase reactive power. For that, you have to divide 576.42 by 3. Then the per phase reactive power will be coming up with 192.14 volt ampere reactive power. This will be equal to I square into XC as usual. So from this I can say capacitive reactance XC equal to 192.14 divided by current. Same current only flowing into the network, 2 square. So if I am dividing it by 4, it will be giving the value of 48.035. We found the value of XC. XC is equal to 48.035. We know Xc can be replaced by 1 by omega c. I am just considering the magnitude 48.035. So here I just wanted to know the frequency of the network. They haven't given, but we know according to Indian standard system, when the frequency is not given in the question, I told you that take by default the Indian power frequency. So it will be 50 Hz. If I will substitute f equal to 50, then omega will become 314. From this, the value of c equal to, finally, where can I write? 1 minute. We don't have space, so I'm clearing this option. Enough. So finally, 1 upon omega c equal to 48.035. So c will become 1 upon 48.035 into 314. 314 is the omega value, right? So if you are multiplying and take the reciprocal, you'll be coming up with 6.62 into 10 power minus 5. So I am multiplying it by 10 power minus 1 divided by 10 power minus 1. See, this 10 power minus 5 into 10 power minus 1 will give you micro. If you bring the denominator 10 power minus 1 to the numerator, it will become plus 10. So basically the value of capacitor finally will become 66.2 microfarad. This is the correct answer. So the value of resistor is 36 ohm. The value of the capacitor is 66.2 microfarad. I hope all of you got the same answer. See, this is how we are analyzing the circuit, and it's not a big deal. You must be careful with the three-phase network. Three-phase means what are the things that we need to consider, what are the things that we can negotiate. That things are very important. That things you must keep it in your mind. Okay. Now, chalo, take the next question. So here what they told is this is phase A, this is it should be phase B, this is phase C. And here they had given all the data. The voltage in phase A, VAN means voltage from A to neutral. That is per phase voltage. Phase A per phase voltage, phase B per phase voltage, phase C per phase voltage given. Individual phases. Now find the value of resistor R in such a way that the current flow through the neutral line will become 0 ampere. That is the question. I hope you got it. Find the value of resistor RC. First of all, this given network is unbalanced. This given system is having unbalanced load. If you observe, unbalanced load. Why it is unbalanced load? What is the difference between balanced load and unbalanced load? The difference is in case of balanced load. First of all, tell me what is the meaning of balancing? Balancing in the sense all side weight should be same mechanically. இப்போ நம்ம கடைக்கெல்லாம் போனோம்னா அந்த தராசு தட்டுன்னு ஒன்று வச்சிருப்பாங்கல்ல, அங்க பேலன்சிங் பார்த்தீங்கன்னா தராசு தட்டு எப்படி இருக்கும்? It should be like this. அதாவது I am talking about analog older one, not the newer one that we are following. It will be like this. இப்படி தானே இருக்கும். இதில் பார்த்தீங்கன்னா ஒன் சைடு வந்து அந்த வெயிட்டேஜ் வச்சிருப்பாங்க, அந்த இரும்புல இருக்கும் இல்லையா? இன்னொரு சைடில் வந்து காய்கறி வாட் எவர் தட் யூ பீப்புள் ஆர் ஆஸ்கிங், அதை இங்கே போட்டுட்டு என்ன பண்ணுவார், அவர் வந்து இந்த இடத்துல பிடிப்பார், அதை செக் பண்ணி பார்ப்பாரு. ஸோ ரெண்டு பக்கமும் பேலன்சிங் அப்படின்னா மீனிங் என்ன? இட் ஷுட் பி ஸ்ட்ரெயிட்டாக வந்து ஒரே ஹரிசாண்டல் லைனில் இதை நிற்கணும். அதுக்கு என்ன பண்ணுவாங்கன்னா இந்த இடத்துல ஒரு நிப்பு வச்சிருப்பாங்க, அதை செக் பண்ணி பார்ப்பாங்க. அது ஸ்ட்ரெயிட்டாக வெர்டிகலாக நிற்கணும் 0 டிகிரி பொசிஷனில், அதாவது 90 டிகிரின்னு சொல்லலாம், ஷார்ப்பாக ஜீரோலேருந்து. That is called balancing. So in the same way in three-phase system, balancing in the sense, so what we have understand, balancing in the sense both sides weight should be same. Similarly, in both sides impedance should be same. That is called balanced load. That is one way. But if you observe the network, this is unbalanced load. In case of unbalanced load, there may be a chances of getting, see, when your load will become unbalanced, then addition of these three phases may not be equal to 0. In that case, what will happen is this addition of three-phase current IA plus IB plus IC may produce one more current that is called a neutral current. That neutral current will be going through the neutral line. It is available in star. We know in star connection we will be having 4 wires. But in delta it is not possible. It could be possible only in star connection. So here, when your load will become unbalanced, automatically there will be chances of getting neutral current. That current will be basically flowing through the neutral line. But in your question, the twist is, we know the load is unbalanced. When the load is unbalanced, there may be a chance of getting neutral current. Now, make the value of neutral current to 0 ampere. இப்போ இந்த நியூட்ரல் கரண்ட் வந்து 0 ஆகணும். லோடு வந்து அன்பேலன்ஸ்ட் ஆயிடுச்சு, அதனால நியூட்ரல் லைன் வழியா கரண்ட் ஃப்ளோ ஆகிறதுக்கு சான்சஸ் இருக்குது. அப்போ நியூட்ரல் லைன் வழியா போற கரண்ட் 0 ஆகணும் அப்படின்னா வாட் கேன் பி தி பெஸ்ட் பாசிபிள் வேல்யூ ஆஃப் ரெசிஸ்டர் ஆர் தட் யூ கேன் புட் into the phase A such that the neutral current will become 0 ampere? That is the logical question. Now take your time. You can take 2 to 3 minutes. I just wanted to know the value of answer because it is very simple question. I had given everything to you. Just try to solve and drop the answer in the comment section. Do it first. Anyone? Just drop your answer in the comment section. Everything is given in the question. I don't think too much of time is required for this question. You can solve it in the easiest way. See, take your own time. I'm not going to give the answer for this question because, see, other phase impedance values are clearly given, phase voltage is clearly given, and it is not a difficult task to figure out the resistor value. So now consider this question as the homework question. Try to solve it by yourself, and you can keep posting the answer in the comment section. Sorry, in the Telegram group, such that you can keep the interaction between your friends and may let you know உங்களுக்கு யாராச்சும் ஒருத்தருக்கு கரெக்டான ஆன்சர் வரலாம். But I'm just giving, see, clue they given already. Neutral current is 0 ampere. When this current will become 0 ampere, you can replace it by 0. Now, how will you write down the current for phase A? Phase A voltage divided by phase A impedance. Phase B voltage divided by phase B impedance. Phase C voltage divided by phase C impedance. For phase B, voltage also known, impedance also known. For phase C, voltage also known, impedance also known. For phase A, voltage is known, only resistance is not known. Substitute all the values. The one and only unknown is R. Reduce the network, you will get the answer, the equation. That's all. It's not a big deal. Correct now? Just think a little, make it a little bit interesting. Sure. So almost I have covered all the basics that are required in case of three-phase circuit. So here I am willing to drop few more questions for your attention. இப்போ ஒரு த்ரீ ஃபேஸ் நெட்வொர்க் இருக்கு அப்படின்னா, let us take ஒரு த்ரீ ஃபேஸ் நெட்வொர்க் இருக்கு அப்படின்னா, அதுல ஒரு ஃபேஸ் வந்து சடனா வந்து டேமேஜ் ஆகுதோ இல்ல ரிமூவ் பண்ணாங்க அப்படின்னா என்ன நடக்கும்? டேமேஜ் ஆர் இட் மே பி ரிமூவ்ட். In the condition, in the மாதிரி situation வரும்போது, I have two questions. One is, what is the resultant magnitude of voltage, current and power? This is my first question. And second question, what about the phase sequence? Phase sequence in the sense what? We know when our system will be in three phase, so basically we will be having 0, 120 degree, that is minus 120 degree plus 120 degree phase shifting between three phases A, B, C. Now out of this three phase, some of the phase will get damaged suddenly. Under that situation, what will be the resultant phase sequence? Anyway, out of three, one will be removed. With the remaining two phases, for the remaining two phases, whether the sequence will be remain same or it will be changed. These complete things you should analyze for both star connected system and a delta connected system. If you will get the complete idea about this, then do let me know in the Telegram group. Drop your answer. You can write the elaborate explanation, but I need answer with the proper explanation. If you understand these things properly, then your three-phase circuits, electrical machines, power system will become very easy, because you might have observed there are so many questions. When your three-phase transformer is delta connected, what will happen is they will take three single-phase transformers. With the help of three single-phase, they will make the delta. Suddenly one line will get damaged, or it may be go for service. Service means they will cross check everything. Another condition, can we operate the circuit with the two transformers? If we operate the transformer in the with the two phase, what will happen? Is there any reduction in the power value, voltage value, current value, efficiency? You can check. How will you calculate the efficiency? That is very simple. You know, you have to check the losses when one transformer